Hi everyone, in this video we are going to see how to express a trigonometric ratio in terms of the other trigonometric ratios. Now in order to do that we are going to use the known identities. I have already made a note up here. So we are going to be using the reciprocal identities, and then also we are going to use the Pythagorean identities and the quotient identities. So there are 3 reciprocal identities and 3 Pythagorean identities and 2 quotient identities. So using these identities we will be converting each of the trigonometric ratios in terms of the other trigonometric ratios. So let's get started. So suppose we need to express sine theta in terms of cosine of theta, right? So how we are going to do it? Well, if you look at all of these identities that I have here, there is one of the identities right here that you can clearly see, which is the first of the Pythagorean identities. Sine squared theta plus cosine squared theta is equal to 1. So using that one, we can easily convert sine theta into cosine of theta, right? So let's try that. From here, can we say that sine squared theta would be equal to 1 minus cosine squared theta? And then from there, if you take square root on both sides, then it would be sine theta is equal to square root of 1 minus cosine square theta. So now you see that we have already expressed sine theta in terms of cosine of theta. Now let's try to convert sine theta into tangent of theta. How are you going to do it? Well, we can do it like this. Can we write sine theta as sine theta over cosine theta multiplied by cosine theta? And as you can see, I had written the cosine theta in the denominator, and now also I have multiplied by another cosine theta, so that sine theta still remains as sine theta. I'm just changing the look and feel, but the value is still sine theta, right? Now from here, you see the first portion is tan theta. Now we can easily see that the first portion is tangent of theta. So let me write it like this. So that is tangent of theta multiplied by cosine of theta. Now if you think about cosine of theta, can we write it as square root of cosine square of theta, and which is equal to, let me keep the tangent of theta as is, and for cosine square theta, can we write it as 1 over secant square theta, because cosine is a reciprocal of secant, or secant is a reciprocal of cosine. So in place of cosine square theta, I am writing 1 over secant square theta, and then that is equal to our tangent of theta, which is outside of the square root, it will stay as is, and then square root of 1 is obviously 1, then divided by square root of secant square theta, and you see we already have a Pythagorean identity there that secant square theta is equal to 1 plus tan square theta. So in place of secant square theta, can I write 1 plus tan square theta? And then finally let's write the tangent of theta as the numerator, and then in the denominator we have square root of 1 plus tangent square theta. So now you see how we have converted sine theta into tangent of theta. Now the value of sine theta is looking everything tangent here. So tangent of theta divided by square root of 1 plus tangent square theta. Similarly, let's try to convert sine theta into cosecant of theta. That's pretty easy. That's actually one of the identities anyways, because if you look at the reciprocal identities, we know that cosecant theta is equal to 1 over sine theta. Similarly, we can say sine theta is equal to 1 over cosecant theta because they are reciprocal of each other. So then converting sine theta into cosecant theta is pretty easy. So I'll just quickly write it down here. So you can say, okay, if I have to write sine theta in terms of cosecant theta, it is going to look like this. Right? Now let's try to do sine theta into secant of theta. To convert sine theta into secant of theta, we can use one of the Pythagorean identities, which is we have already converted sine theta into cosine theta. So let me write that down, 1 minus cosine square theta, that we have already shown it in the first activity there. Now from here, can we say, okay, this should be equal to square root of 1 minus 1 over secant square theta, because cosine theta is equal to 1 over secant theta. They are reciprocal of each other. So in place of cosine square theta, I am writing 1 over secant square theta. And if we simplify this a little bit, we will be getting square root of, in the numerator, we are going to have secant square theta minus 1 divided by secant square theta. So we can write it as square root of secant square theta minus 1 and divided by, if I take the secant square theta outside of the square root, it will become secant theta. So we have been able to write sine theta in terms of secant theta. Now you see in this value, there is no other ratio, only secant theta. We are saying that secant theta. So if somebody says, hey, if secant theta is this, what is the value of sine theta? You can directly use this formula here. Well, it's actually not a formula. You can call it identity because we are going from one form into another form, but the actual value is not changing. Now let's try to express sine theta in terms of cotangent theta. We know that sine theta is equal to 1 over cosecant theta, and there is a Pythagorean identity which relates the cosecant and the cotangent. That is why I am going this route. So let's write it as 1 over cosecant theta, and then can we write it as 1 over square root of cosecant square theta, and then I'm going to write it as 1 over, we know that cosecant square theta is equal to 1 plus cotangent square theta, so this will become 1 over square root of 1 plus cotangent square of theta. So now you see our sin theta is looking very simple. In terms of cotangent of theta, it is equal to 1 over square root of 1 plus cotangent square of theta. So you can see how easily we can convert a trigonometric ratio in terms of other trigonometric ratios, right? Similarly, let's try to convert cosine of theta in terms of the other trigonometric ratios, right? So now we are going to do the same kind of exercise for cosine theta. So first we are going to try and convert cosine theta in terms of sin theta. We know that there is a Pythagorean identity between cosine and sin theta. We know that sin squared theta plus cosine squared theta is equal to 1. So from there we can say, okay, can we write cosine theta as square root of cosine squared theta? I just need to convert into square. So that is why I am using square root, and then I am writing cosine squared theta. And then in place of cosine squared theta, I am going to write 1 minus sin squared theta. So that would be square root of 1 minus sin squared theta. That's it. So this is how you convert cosine theta into sin theta. Now let's try to convert cosine theta into tangent of theta. To go to tangent, it would be easier to convert it into secant, and then from secant we can go to tangent easily, right? So let's first convert into secant. So we can write it as 1 over secant theta, and then we can write it as 1 over square root of secant square theta, and then we know that secant square theta is equal to 1 plus tangent square theta. So that would be square root of 1 plus tan square theta. So you see how easily we can convert cosine theta into tangent theta. So cosine theta is equal to 1 over square root of 1 plus tangent square theta. Now let's try to convert cosine theta into cosecant theta. We can easily use the Pythagorean identity, which is this is equal to square root of 1 minus sin square theta, and then in place of sin square theta I am going to write 1 over cosecant square theta. So this will be 1 minus 1 over cosecant square theta, and that would give us square root of cosecant square theta minus 1 whole divided by cosecant square theta, right? And then we can write it as square root of cosecant square theta minus 1, and then we can bring the other cosecant square theta outside of the square root, so this will become cosecant theta. So if you know the value of cosecant theta, you can easily calculate the value of cosine theta. So cosine theta will be square root of cosecant square theta minus 1 whole divided by cosecant theta. Now let's try to convert cosine theta into secant theta. That's extremely easy. That's just one of those reciprocal identities. So we can simply write it as cosine theta is equal to 1 over secant theta. And now we are going to convert cosine theta into cotangent theta. So if you can do this little trick, we can write it as cosine of theta divided by, I am forcefully dividing it by sine of theta, because I know this will give me cotangent of theta, and then I am multiplying by sine of theta. So from here we get cotangent of theta times sine of theta. Can we write it as square root of sine squared theta? And then we are going to write it as cotangent theta, which is outside, it will stay as is, cotangent theta times, can we say that this is square root of 1 over cosecant squared theta, and then this will be equal to cotangent theta times square root of 1 over cosecant squared theta is equal to 1 plus cotangent squared theta. So then we can finally write it as, in the numerator we are going to have cotangent theta and square root of 1, so it will be just cotangent theta, and then in the denominator we are going to have square root of 1 plus cotangent square theta, right? So now you see cosine theta has been written in terms of cotangent of theta. Now let's try to convert tangent of theta in terms of sine of theta. Now we know from the quotient identities that tangent of theta is equal to sine theta divided by cosine theta, and then for sine theta we are going to keep it as is, and for cosine theta we are going to write it as square root of cosine square theta, and from here we can say, okay, this must be equal to sine theta over square root of 1 minus sine square theta. That's the Pythagorean identity. We know that sine square theta plus cosine square theta is equal to 1. So cosine square theta can be written as 1 minus sine square theta, and that's exactly what I have done here, right? So now you see tangent of theta has been written in terms of sine theta. Now let's try to convert tangent of theta in terms of cosine theta. So we can keep the cosine theta as is, but for the sine theta, can we write it as square root of sine squared theta? And then from here we can say, okay, this is definitely 1 minus cosine squared theta. that's from the Pythagorean identity, and then divided by cosine of theta. So you see tangent of theta now looking like square root of 1 minus cosine square theta whole divided by cosine of theta. That's the value of tangent of theta. Now let's try to convert tangent of theta into cosecant of theta. From the reciprocal identity, we know that tangent of theta is equal to 1 over cotangent of theta, and then we can easily write it as 1 over square root of cotangent square theta. And then we know that cotangent square theta is actually equal to cosecant square theta minus 1, because we have a Pythagoras identity that says that cosecant square theta is equal to 1 plus cotangent square theta. So cotangent square theta would be cosecant square theta minus 1. That's exactly what I have done here. So now you see we have been able to express tangent of theta in terms of cosecant of theta. Now we are going to convert tangent of theta into secant of theta. Can we write it as square root of tangent square of theta? Because there is a nice Pythagorean identity which relates secant and tangent together. So I'm trying to use that one. So here we can say, okay, this must be square root of tangent square theta, and then using that Pythagorean identity we can easily say that, okay, tangent square theta must be secant square theta minus 1, because we know that secant square theta is equal to 1 plus tangent square theta. And then for cotangent of theta, meaning converting tangent of theta into cotangent of theta, that's just a direct reciprocal identity, so we can simply write it like this, 1 over cotangent of theta. Next we are going to convert cosecant theta in terms of the other trigonometric ratios. If we have to convert cosecant theta into sin theta, it's very easy. It's a direct reciprocal identity here. And next we are going to convert cosecant theta into cosine theta. You can say, okay, cosecant theta is equal to 1 over sin theta, and then we know that sin theta is equal to square root of 1 minus cosine square theta. So now cosecant theta has been written in terms of cosine of theta. Next we are going to convert cosecant theta into tangent of theta. Can we write this as square root of cosecant square theta? And then we know that cosecant square theta is equal to 1 plus cotangent square theta. So I am going to write here that this is equal to 1 plus cotangent square theta. And then what is cotangent square theta? Well, cotangent is 1 over tangent. So we can say this is 1 plus 1 over tangent square theta. And then if we simplify that, this will become square root of tangent square theta plus 1 divided by tangent square theta. And then if we keep the square root in the numerator, then we are going to have tangent square theta plus 1 whole divided by this tangent square theta from the denominator can come out as tangent of theta. So this is how we can convert cosecant theta into tangent of theta. Now let's try to convert cosecant theta into secant theta. So we can write this as 1 over sin theta, which is equal to 1 over square root of sin square theta, which is equal to 1 over square root of, now I am going to use the Pythagorean identity, so this can be written as 1 minus cosine square theta, and then that can be written as 1 over square root of 1 minus 1 over secant square theta, because cosine theta is equal to 1 over secant theta, they are the reciprocal identities. So then from here we can see that, okay, this is now becoming 1 over square root of, then here again we have secant square theta minus 1 divided by secant square theta inside the square root. And then if we take out the secant square theta from the lowermost denominator, then it will come to the top, it will come to the numerator, and outside of square root it will become secant theta divided by square root of secant square theta minus 1. So you see how we have converted cosecant theta into secant theta, and finally we are going to convert cosecant theta into cotangent theta. So let's do that. And there is a nice Pythagorean identity between cosecant and cotangent. So let's write this as square root of cosecant square theta, which is equal to, we know that this is equal to 1 plus cotangent square theta. So we have been able to convert cosecant theta in terms of all other trigonometric ratios, right? Next we are going to convert secant theta in terms of the other trigonometric ratios. So let's get started. First we are going to convert secant theta into sine of theta. So what is secant theta? Secant theta is the reciprocal of cosine. So we can write it as 1 over cosine of theta, and then we already know that cosine of theta is actually square root of 1 minus sine square theta. So this is the value of secant of theta. So secant of theta is 1 over square root of 1 minus sine square theta. Now let's try to convert secant of theta into cosine of theta. Well, that's pretty easy. We already have the picture right in front of us. So let's just quickly make a note here. So secant of theta in terms of cosine of theta, it is very simple. It's just the reciprocal relationship here. So it would be 1 over cosine of theta. So we have expressed secant of theta in terms of sine of theta, and then we have expressed secant of theta in terms of cosine of theta. Next we are going to express secant of theta in terms of tangent of theta. So secant of theta, can we say this is square root of secant square of theta? And then we know the Pythagorean relationship, which is secant square theta is equal to 1 plus tangent square theta. And that is the value of secant theta. So secant of theta is equal to square root of 1 plus tangent square theta. Now let's try to express secant of theta in terms of cosecant of theta. In point number 21, we just saw that secant theta is equal to 1 over square root of 1 minus sine square theta. So let's write that down here. And wherever we have sine square theta, I'm going to write it as 1 over cosecant square theta. And then from here, what do we get? Well, we get 1 over square root of cosecant square theta minus 1 whole divided by cosecant square theta. And from here, we can say, okay, this is equal to, see the cosecant square theta at the bottom, it will come to the top, because if we flip it, it is actually 1 over, it is in a reciprocal form. So then if we flip it, then it will become 1 multiplied by square root of cosecant square theta divided by cosecant square theta minus 1. And this is nothing but cosecant theta. So coming out of the square root, this will become cosecant theta divided by square root of cosecant square theta minus 1. And this is the value of secant theta in terms of cosecant of theta. Next, let's try to convert secant of theta into cotangent of theta. So we know that secant of theta is actually square root of 1 plus tangent square of theta. And then from here, can we say, okay, this must be then square root of 1 plus, wherever we have tangent square of theta, I am going to write 1 over cotangent square of theta, because tangent and cotangent, they are reciprocal of each other. So wherever we had tangent square of theta, I wrote 1 over cotangent square of theta. And now if we simplify it, it will become square root of cotangent square of theta plus 1 whole divided by cotangent square of theta. And this will be equal to square root of cotangent square of theta plus 1, and then whole divided by, if we bring the cotangent square theta outside of the square root, it will become just cotangent of theta. So this is the value of secant of theta in terms of cotangent of theta. So that covers all the conversion for secant of theta, and now we are left with the cotangent of theta. So now we are going to try and convert cotangent of theta in terms of the other trigonometric ratios. So first we are going to convert cotangent of theta in terms of sine of theta. So what is cotangent of theta? Well, this is cosine over sine. And then what is cosine? Well, cosine we already know, it is square root of 1 minus sine square theta and divided by sine of theta. And this is the value. So this is the value of cotangent of theta in terms of sine theta. Now let's try to convert cotangent of theta in terms of cosine of theta. Now here, because we are trying to convert it into cosine of theta, so we already have the cosine theta in the numerator, we are going to keep it as is. And then in the denominator we have sine of theta, that would be square root of 1 minus cosine square theta. So this is the value of cotangent of theta in terms of cosine of theta. Next we are going to convert cotangent of theta in terms of tangent of theta, and that's very easy. Actually, it's the reciprocal ratio. So let's make a quick note here. Cotangent of theta is actually equal to 1 over tangent of theta. Next, we are going to convert cotangent of theta in terms of cosecant of theta. We already know there is a relationship between cosecant and cotangent. Cosecant square theta is equal to 1 plus cotangent square theta. So we can write it as square root of cotangent square of theta, and then this is going to be equal to cosecant square theta minus 1. And this comes from the Pythagorean identity that we know, which is cosecant square theta is equal to 1 plus cotangent square theta. This is an identity we already know, and using that identity, I simply replaced cotangent square of theta with cosecant square of theta minus 1. Next, we are going to convert cotangent theta in terms of secant of theta. So can we write it as 1 over tangent of theta? And then from here, can we write it as 1 over square root of tangent square of theta? And then we can write it as 1 over square root of secant square theta minus 1. This is from the Pythagorean identity, where we know that secant square theta is equal to 1 plus tangent square theta. So wherever we had tangent square theta, I wrote secant square theta minus 1. And this is the value of cotangent of theta in terms of secant of theta. And this brings us to the end of this video. Thank you for watching. See you in the next video.